Okay, so in this video, we're going to be looking at how to write equations for graphs of piecewise functions based on the graph. Now, the process is going to be a little bit different depending on the kind of pieces that you have. We're going to be looking at graphs of piecewise functions that have linear components. But if you have a function that has a rational or a quadratic component, the steps are going to be very similar, but you're going to be basing your segments on the properties of the segment that you have. So if you have a quadratic point to a quadratic function, you're going to need a vertex and a second point, or you're going to need 3 points on the graph in order to solve for your ABC of your quadratic equation, as for example. If you have a linear equation, we're going to use points and slopes to figure out the section of the graph. If you have a rational function, you're going to have to identify the asymptotes and so on and so forth. But we're going to look at the linear pieces because those are the somewhat most common that you're going to encounter in algebra, where you might be asked to write the equation of the function. And then we're going to look at a second one that also has linear segments, but is a little bit more complicated than our first example. But for all piecewise functions, there's going to be a similar process. What's going to change basically is what you do within each step of the process. All right, so the first thing that we have to figure out is, based on our piecewise graph, where, how many pieces we have and where those segments apply. Now, based on our particular function, we're going to have 3 segments. So let's set up our curly bracket, and we've got 1, 2, 3. Nope, that's 4. 3 segments. And the first segment is going to start at -4, since that's where we have a closed circle on our graph. And it's going to go up to this point here where there's another closed circle on our graph, which is going to occur at x equals -1. Now, because these 2 pieces start and stop at the same place, we can choose whether to include the -1 in the first, the -1 in the first piece, or the -1 in the second piece. Since it's not included at this end, I'm going to not include it on either end. And then we'll worry about the function part, but later. But for right now, we're just looking at this, where each piece applies. So for the second piece, it's going to pick up where the first piece left off, so at -1, and then it is going to continue up until it gets to 3. And again, this is an open circle, so it's not included. And then the third piece will go from 3, that's a closed circle, so it gets an equal sign, and then likewise a closed circle, and it stops again at 4. Now, 2 of these pieces are horizontal lines, so those are going to be very easy to figure out because they have no x dependency at all, except for the segment of the graph that they appear on. So this section down here, this third piece, is actually just going to be -2 all the time. The middle section of the piece is a horizontal line at 2, so that's just going to be 2. Get our spacing correct. And then the hard part is going to be this segment right here. We're going to have to come up with an equation of a line. Now, it's not really a good idea to kind of eyeball it from the graph. Instead, what we want to do is we want to figure out what our points are and then come up with an equation based on the points that we have. So this bottom point right here at the end of our graph is going to be -4, and the y coordinate is -3. And the point at the other end is going to be at -1 and y coordinate of 2. So the slope for our line is going to be 2 minus a -3 divided by, that's the difference in our y coordinates, and -1 minus a minus 4. And if we do that math, we get 5 over 3. And then we use our point slope form. Y minus 2 is equal to 5 over 3 x minus, that should be a 3, x minus a minus 1 or x plus 1. And then we just have to do some arithmetic. Oh, I really don't like those 3's apparently. 5 over 3. And then if I add 2 to 5 over 3 for my coordinate, my intercept, 5 divided by 3 plus 2 is going to be 11 over 3. And so that is that denominator. That is going to be the equation of my line. And so finally, this segment is what is defined here for this first piece of our function. And so now we have our complete function for this piecewise graph, our slanted line that applies from -4 to -1, 2 for our horizontal segment from -1 to 3, and then the small section that is -2 going from x equals 3 to x equals 4. And that is the complete graph. Now, if these segments were to go off, continue off to the end of the graph and not stop here, we could get rid of the top end and the bottom end of our graph, but we could still use, for instance, this point here where it crosses the grid as a point in the equation of our line. So we're going to look at another graph, which is also a piecewise graph, and which is a little bit more complicated because there are more line segments. We're going to treat each one of these grids as a single unit, and then we're going to find the equation of our graph from that point. Doesn't really seem to want to wrap around text. All right, so let's identify our points and we'll just draw on the graph so that we can label them. So if this is 1 unit grid lines, then this is going to be -3, 0. And this point right here is going to be -5, 2. And this point right here is going to be 0, 3. And this point right here, 1, 2, 3, this is going to be 3, 1, 2, 3, -3. And then this point right here will be 5, -2. So those are our key points. So let's now come up with our form of our equation, and then we'll start filling stuff in. So we're going to have 1, 2, 3, 4 segments. So 1, 2, 3, 4. And then the first segment, now this is it goes to the end of the graph. So I'm going to assume, even though I'm going to use this point to come up with the equation, I'm going to assume that the line is going to continue off the graph to infinity. So this will just be x less than or equal to -3. Now, because the segments join together, even if they had open circles or closed circles plotted, they would all overlap at the end point. So I don't really know which end is going to have the open circle and which is going to have the closed circle. And it doesn't really matter as long as you don't use both equals to on both segments. it doesn't make that much difference. Now, for the second section, it's going to go from -3 to 0 in the x direction. And I'm just going to put the inequality, the equal sign on all the inequalities at the top end of the region. And then the next section is going to start at 0 and go up to 3. And then the final section is going to start with x greater than or greater than 3, because it's just going to go off to the end. Now, because these are all straight lines, these are going to have to be things that we find the slope for. Now, some of these are going to be a little bit more straightforward than others. This segment, it looks like we're increasing by 2 and decreasing by 2. So this is going to be a slope of -1. This one is going up by 3 and over by 3. So it's going to be a slope of +1. Neither of these are going to be equal to 1. But if you look at the grid lines, I think this one's going to be -2. And this one is going to be half maybe. So they're not nasty values. So let's just go ahead and calculate our equations. So M1, so it's going to be between our 2 points, -5, 2 and -3, 0. So 2 minus 0 in the y coordinates and -5 minus a -3 in the x coordinates, which is going to give us 2 divided by -5 plus 3 is going to be -2. And so we're going to get a slope of -1, which is to be expected. And then y minus 0 is equal to -1x plus 3. And that's going to give us y equals -x minus 3. So this first segment, -x minus 3. And if you were to put a ruler and you would draw this, you could see that, yes, that would intersect as a negative slope, and it's probably going to cross at x equals -3 if the line were to continue. All right, so let's look at the next segment. So this is going to go between these 2 points. And so if I look at the y coordinates, 3 minus 0, and again, the order you subtract in doesn't matter as long as you are consistent. 0 minus a -3. So that's going to be 3 over 3, which is 1, which again, positive slope, that makes sense. And so then our equation is going to be y minus, well, we can use the intercept here. So x plus 3. Since this is the y-intercept, we can just go ahead and use that. So copy, it's going to go there. Add some space just so that it spreads itself out. And then we'll go on to the next segment. M3 is going to go between 0, 3 and 3, -3. So 3 minus a -3 divided by 0 minus 3. So that's going to give me 6 over -3, which is going to be -2. And again, that is a downward slope, so that makes sense. And so our equation then is going to be y, and we have an intercept again, so -2x plus 3. So I'm going to take that, I'm going to put it in my equation. And then we have one more, M4, and that's going to go between these 2 segments. So the y coordinates, -3 minus a -2 divided by 3 minus 5 is going to be -1 over -2, which is going to give me a 1/2 slope. And then y minus a -3 is going to give me 1/2 x minus 3. And if I do a little bit of extra math, and then I subtract 3 to both sides, -3/2 minus 3 is going to be -9/2. And again, you can kind of see that, again, if you extend this line, it's going to cross about right here, which is -4.5, which is what 9/2 is. And we put that there. And again, we'll add a space to spread it out. And so this is our piecewise function represented in this graph. We have our intervals and we have our individual line segments. Now, depending on the kind of problem you're doing, you may or may not need to write the equation of the piecewise function. But if you are asked to write the equation of the piecewise function, basically, again, you're going to identify points on your graph. You're going, if they're straight lines, you're going to use find the slope and use your point slope form or your y equals mx plus b form of the equation to obtain the equation for that segment. If you have more complicated functions, you'll need to identify more points. And then if you have, a quadratic or something like that, you may need to follow the process for interpolating polynomials in order to figure out what those coefficients are going to be. But the basic idea is still going to be the same. You're going to identify some key points and then figure out what the equations are for each of the segments separately. And usually the endpoints are going to be the most useful. And if you need additional points, then usually you will be able to read those off the graph if it's intended to be something that you can do manually.